Okay, let's start. Morning, everyone, and I hope you had a good weekend. I know it's a 9 a.m. lecture, so bear with me. So we're going to continue today where we left off last time, talking about version control and Git. If you remember, we had several problems that we were trying to solve. Basically, when working on software development projects, we needed a way to be able to go back to a previous version of the program. We needed a way to prevent conflicting edits by different team members. And the third one was the most important one. We needed a way to control when we make our changes visible to our teammates so that we are able to test first, make sure that our changes are okay, and then we make them visible. So our solution to all of these problems was what we call a version control system. And here in this course, we are learning one of the most popular version control tools, which is called Git. Before I continue, I have like a kind of a trivia question. It's worth a chocolate bar, whoever knows it. So anyone knows who created Git? You don't? You can't Google it. Did you Google it? Yeah, go ahead. Linus Torvalds, yeah, right. Do you know what else he did? Yes, so he basically developed two of the most popular software tools that we use in our field today, the Linux operating system and Git. Okay, so meet me after class, I'll give you a chocolate bar, yeah. Okay, so can anyone remind me how Git solved problem number 3? Like when we make our changes visible to the teammates, how do we do that? Anyone remembers? No? No one? You should have it in milestone 0. B07, just a second. Go ahead.
You only store the changes.
You only what, sorry?
You only store the changes.
Yes, but how do we do that? Like, there are two commands that we use to...
Git add, git commit, and then you can git push.
Yes, exactly. So we do git commit and git push when we are ready to basically make our changes visible. Thank you. Okay. Okay, what about we haven't talked about problem number 2 yet. We're gonna do that in a minute. What about problem number 1? How do we go back to a previous version of the program that is in a working state? Anyone else? A07. Git checkout, that's correct. So basically, we do a git checkout, and then we provide the hash of the commit that we want to go back to, and basically it fetches a copy of that program at that state of the history. Sounds good. So just to remind everyone, what is Git? Basically, Git consists of a main repository that lives somewhere on some server, and then each collaborator to the project, to the software project, basically has a copy of their own copy of the repository. We call it a working copy or a working tree. And then each copy of each of these copies basically interacts with the remote repository through Git commands. Okay. Okay, so let's talk about how this solves problem 2. That's what we haven't talked about. Basically, we want a way to prevent conflicting edits to by different people. Okay, so in Git, there are two basic, sorry, not in Git, in general, in version control systems, there are two ways to do that. One is called lock-based, where basically we don't let people work on the same file at the same time. This is basically a synchronization approach, and this is used by most of the old version control systems. I don't think you've heard of them. I personally didn't use them before, so don't feel bad about not hearing of them. And then the problem with these is that they don't scale well, especially if we're working in large teams, and it needs some extra overhead to prevent people from editing the same files. Okay. The second approach, which is the most popular one these days, is called a merge-based. And basically, many people can modify the same file independently at the same time in their own working copies. Okay? And then once we finish our edits to those files, we sort out the differences or what we call the conflicts in the main repository only when we push the code. Okay, so this is used by modern systems like Git and SVN, and this is what we're going to use actually if you ever encounter a merging conflict with a teammate. Okay, so how does this work? Let's go back to our example where Tony Stark and Bruce Wayne are basically both working on the same project, and we have a Git repository in the shown here in the middle. Okay, and then Tony is edited the red file, he pushed these changes, committed, and everything is fine. Now the remote repository is basically updated with the red changes. Okay, so we have now R2 here. Yeah, R2 basically that reflects the changes made by Tony. Okay. Now, at the same time, Bruce was editing the green file, which is a different file from Tony's file. And he tried to commit and push, but then he got this weird message from Git that we cannot do a fast forward merge. Why is that? Because the working tree of Bruce now doesn't reflect the latest history of the main repository. So anyone has like a solution, like what does Bruce need to do in this case before he continues? We need to make sure that he updates his version to the latest copy. What is the command to do that? Anyone knows? We talked about it last time. Come on, guys, you don't like chocolate bars? I'll give you a chocolate bar if you know. Okay, so I guess no one. Basically, we need to do a git pull. Okay, we need to pull the changes and make sure that our working copy is updated. Once we do that, now Bruce has the red changes from Tony on his working copy, okay? And he tests, again, a very important thing. The first thing we do when we pull is try to build the program and test it, make sure that there are no issues. Now let's say that Bruce didn't find any issues, that's perfect. Now he can commit and push his code, and Git shouldn't give him any errors anymore. And basically now we have R3 here, where both the red changes and the green changes are on the main repository. Okay. But all that is good. Now, what if they both edited the same file, both in their own working copy? What will happen? So now, let's say Bruce is committing first. Oh, no, sorry. Tony has already committed his changes. We see that red changes are in the main repository. Now, Bruce got the same message again. He can't do a forward merge. He had to pull first, okay? Now, he pulled. Okay, now, Git is a bit smart. Basically, it sees that both Bruce and Tony did the changes on the same file. In this case, let's say that they both edited a section of the file that is not interacting with each other. What this Git does, it basically tries to merge it automatically, okay? And in this case, basically, it will succeed because they're changing different parts. Once once the changes are done, basically Git continues with the pull, and then you can push your code as is. Now, let's say that there were certain lines that were overlapping between the two changes. Okay, Git will give you that there is a conflict, and it cannot resolve it manually. It's not that smart. Basically, you have to go read the code, make sure that one of the changes stays, or both. You can merge both changes manually if you know what exactly is happening. Okay, and this is what we call by resolving conflicts. So how do we do that? I'm going to give you an example here. So let's say we have this conflicted file, and this is file1.cpp. The first section here is showing that this section of the file here was only edited in R1, okay, so there were no conflicts in here. And then in the sections that there are conflicts in the file, Git will basically annotate the file for both changes. The first thing you're going to see is that this series of less than sign and then a head. This basically tells us that the head of the repository points to a remote copy that has this line. So, sorry, the head points to the working copy. So Batman, when Bruce was trying to merge his changes, he saw that he added this line. His head points to this, while the remote repository basically points to the whatever on the next to the greater than sign. Okay, so on the remote we have Iron Man is the best. Locally we have Batman is the best. So what we do is basically Bruce goes and edit the file manually. He removes one of these lines if he wants, and he can also change the whole thing and just give one clear cout statement. And he saves the file. Once he saves, basically there is a command. I'm not going to go over it in detail. Basically, you just tell that you tell Git that continue rebasing or continue merging, and it will try to continue resolving extra edits if there are any. And then once it's done, it's going to give you okay, all good. Now you can push and commit and push. So, any questions so far? Okay. Now we know, by the way, we are teaching you a lot of commands. We're not trying to tell you that you have to memorize all of these, but with practice with Git, you'll notice that, okay, all of these now come to mind very quickly because you're probably gonna use them a lot, even in in our project here. Okay. So far, I've been telling you a little bits and pieces about Git and the different commands that it supports. Now, let's talk about a more general way and see how Git works in practice, okay? How everything works together. So far, what we've talked about is that each one has a working copy of the program and there is only one main repository. It's not actually the case. Basically, in real Git systems, or in real any version control system, there is the main repository that is hosted somewhere. And then there are also two what we call local repositories. Basically, each one has his own local repository on his own machine. And Git did that for scalability, basically, and if there are any network issues. So this allows multiple users to work on the same project at the same time, even if there is no network access. So basically, each one does his changes, commits, and pushes to his own local repository. And once everything is clear, they can push to the remote repository. Okay, so let's say I am working with ATA on a project, on our mapping project that we're gonna learn about next lecture. And both of us have their own working copy, mine and Alex's, okay? So the remote repository in this course is going to be hosted on the UG machines that you are working on. It's on in some root access directory that you don't have access to. And it hosts all of the Git repository by all groups, okay? In real scenarios, usually there is a service that hosts these remote repositories. Anyone knows of a popular service that people use to host remote Git repositories? Anyone heard of GitHub? Yes, okay, so GitHub is basically a service that provides remote repositories to users. It's widely used. We at Cerebras use it, for example, and you can host your private repository, so it's not accessible to any external audience, or you can make it public. Okay. With the remote repository, by the way, again, each one of us has their own local repository. With the remote repository, there are only few commands that can interact with the remote repository. They are push, pull, and fetch. Fetch basically is like pull, but it doesn't actually gives you the changes directly. It just tells you that it updates the history to know what has changed on the remote repository. So it basically tells the user, oh, there are some changes on the remote repository that you don't have it yet. So if you want, you can pull it. Okay, so let's say I did some changes on one of the files, then I did a git add and commit. We haven't talked about add yet. What add does is basically we've only talked about commit. Commit basically pushes, it tells the Git that all of my changes are going to be committed to, later to the remote repository. What add does is that it tells Git to track the files that I want to change or that I want to be committed later. So let's say I have some scratch file that I was doing some experiments on, or like I was writing some notes on. I don't want my teammates to see that, basically, so I don't add that. So with git add, you specify the files that you want to push. You can do a git add dot. Git add dot basically adds all of the files that Git sees in this directory and all of the subdirectories. So be careful when using that. Just make sure that you don't want any files not committed be there. Okay, so we add and commit. Now when we commit, the changes are only reflected in my local repo. So it's kind of a git push, but it's a pushing to my local repository. So my teammates still can see it. The remote repository still doesn't know about these changes. Okay? So once I do the push basically takes my changes and puts them on the remote repository that now my teammates can pull. So Alex, now, he does a git status. We also didn't talk about git status. Git status basically, it asks Git if there are any local changes that haven't been committed yet, and it gives you a list of files where changes are, where the changes are. So if you added a certain file through git add first, and then you did a git status, you will see that file highlighted in green on the terminal. And basically this is telling you that, by the way, you have changes here. Just make sure that if you want to commit them or not. Okay? When he does git status, in this case, when Alex does git status, he won't see my changes. Why? Basically, he hasn't pulled my the changes yet. He hasn't pulled the remote repository yet. His local repository, so git status only talks with the local repository. The local repository still doesn't have my changes. Okay? So he will only see this once he does a git pull. Okay, so let's say Alex did a change on a different file. He did a git add and a commit. Now his changes are reflected only in his local repository. And when he pushes, what will happen? Anyone knows? We just talked about it like 5 slides earlier. So basically, I added my changes, I pushed my changes, Alex added new changes, and he tried to push. What will happen? Yes, Don. Yes, you need to pull the changes. Git, again, will give you a command, give you an error saying that we cannot do a fast forward merge. What does that mean? It's a vague statement, but what it means is that there are changes. I know that there are changes on the remote repository that you haven't seen yet. So you just need to make sure to pull those changes first, try to resolve the conflicts if there are any, and then commit and push. So, Alex will pull, and now that my changes will be reflected in his local repository and in his working copy. So the red changes. In this case, we both worked on different files, so I don't think Git will complain. So the first thing, again, we do is test. Here, I'm not showing it, but we build and test, try to make sure that everything is working fine, and then we push. Once we push, now all of the changes are in the remote repository, both mine and Alex's. Any questions so far? Nope, great. Okay, and this is the usual coding routine when you work on with teams, whether in small or big teams. The first thing you do is always try to git pull. If you remember, we talked about this code git pull -r. I'm going to talk about the -r in a little bit, but for now, just know that it makes the history clean when it tries to merge all the changes between the local and the remote repository. So we do a git pull -r to get the latest code on the master copy on the main repository. We fix any bugs that we notice, like after we build and test, or we do our own feature development. And once we're done, we do a git add, a commit, and then we push. And we do this over and over again. So the git push, I think there is a error with the arrow here. The git push will basically fail again if there are changes on the remote repository that we haven't seen on our, or we haven't pulled to our local copy first. So we will have to repeat the cycle if there are any. We pull, build, test, and then push. Okay, so always, especially when working on a project, yeah, sorry, B06, just a second. Go ahead.
If you git pull, does that overwrite the changes that you made to the file?
No. So as we said, basically git pull is a bit smart. It tries to first sees if there are conflicting changes between you and whatever is on the main repository, and then it tries to merge them automatically. Let's say there were some changes on a different file that you haven't edited, then it will see that, okay, I can merge them automatically and everything will work fine. Both the changes will come. If there are conflicting changes, then it will complain that I cannot continue the pull. You have to first resolve these conflicts manually, and then you save the changes and tell Git, okay, you can continue pulling. This way, Git avoids basically overriding any changes of any team member and making sure that the developers know what is happening exactly, right? Okay, so yeah, basically when working in teams, the first thing always you do is to try to do a git pull first. Even if there are no changes on the remote, you just, in this case, know that, okay, it's safe to continue working. Because it might happen that you forgot to pull, you did a lot of changes, let's say for a week, and then, oh, you try to push, there are some, it will complain, you try to pull, and there will be a lot of conflicts. Resolving conflicts is not an easy task, it's very tedious, and especially if you were working, for example, in a company where you don't even know all the developers contributing to the main repository, so you don't know the whole, all of the code that is being pushed, and trying to resolve them one by one is really annoying, believe me. So always do a git pull first. Okay, before we continue, any questions on, yeah. Sorry, can you speak in the microphone? Yeah. Yes, we're going, git pull -r means rebase. So there is something called merge and rebase. We're going to talk about it at the end of the slide deck here. For now, basically, git rebase reserves the history of all the changes. I'm going to explain it in a bit more in detail on what is the difference between a merge and rebase. But usually I prefer to use a rebase because it keeps things clear when looking at the log, for example, and making sure who did what, okay? I think it will be clear when we talk about branching in a little bit, and there is a difference between the merge and rebase, okay? Any other questions? Okay. So I'm going to teach about another concept of Git that is very important usually in practice. It's not, you may not use it in this course because you are working in a smaller team. You can if you want, but just be prepared to resolve conflicts. And this is called branching. Okay. So what do we mean by branching? Or let's see what is the motivation behind branching. So let's say Tony Stark is finishing off milestone 1. The team finished all of the required APIs that they needed to build, and then they are working on, they are starting to work on milestone 2. But let's say that Tony is still annoyed about certain bugs that he wanted to resolve, okay? While Bruce didn't want to wait for those bugs to be resolved, and he wants to get a head start on milestone 2, for example. Okay, so so both of them want to work on different changes without trying to conflict each other. Okay, we don't want to make major changes from milestone 2 on top of the code that's for milestone 1 before submission, because we might run into issues where we're trying to resolve last-minute bugs, and we don't want to do that. So the solution to this is to do branching. Okay, basically each one of the team members basically will work on their own, on top of they're working on their own working tree, they're working on their own branch. So what do we mean by branch? In Git, there are two main pointers called master and head. Master is the reference to the, master is basically a pointer to a commit to the tip of the branch, or the main branch that is seen by all team members, okay? You can call it doesn't have to be called master, you can call it whatever you want. Conventionally, everyone calls it master. And it is usually the most important and long-lived branch, okay? So all the developers basically always try to push their changes to the master branch, okay? Sometimes it's called, by the way, main in other tools, version control tools, but in Git it's usually called master. And then the other pointer, it's called head. Head is a pointer to the branch that you are working on. So whatever branch you are working on, your local copy, head will be pointing to the commit at the top of that branch. So usually, when you don't do any branching, you are also working on master that is on your own copy. And head will point to the same commit that is master pointing to, okay? But when each developer has their own branch, head will point to a different commit for each team member, okay? So each developer has their own head. So what do we mean by branching? Now let's say this is the status of the master branch, okay? The main branch again. So we did like R99, R100, R101. At the point of R101, Tony decided to branch off of master and try to create a new branch that is only for milestone 1 specifically. Okay? So the way we do this is through, remember the git checkout commit, git checkout command that allows us to go back in history or change to a different commit. We can also use it to create new branches. So with a git checkout -b, you can basically create a new branch and you give it the name that you want. In this case, Tony decided to give it finish M1. Can you see my pointer? Yeah. So finish M1, basically, that's a new branch he wants to work on and makes new changes on top of it. So once the finish M1 is created, now the head pointer of Tony's is pointing to the tip, the commit at the tip of finish M1. So here you can see that master or Bruce's head is still pointing to master, while Tony's head is pointing to finish M1. Both of them are still at the same commit, R101. Now, each one proceeds working independently, and let's say that Bruce still continues working on master. He's developing milestone 2 now, and he did some changes, he commit and push. So the master branch on the remote repository now reflects R102, which is still the same branch that Bruce is working on. While Tony is still working on finish M1 branch, and his head is still pointing to the R101. He does some changes. Now you can see that it's branching. It's like a tree. So when he did some changes, he commit and pushed them. And what he pushed now to the main repository is a completely new branch. It's called finish M1. Each one proceeds independently. You can see here. And let's say at this point at R106, Tony tests, builds and tests, and he sees that, okay, all of the bugs for milestone 1 are fixed, and they are ready to be merged back to master. So we want to submit our milestone 1, but at the same time, we don't want to lose all of the changes that Tony did to fix all of the bugs, because we might encounter them later on when we continue developing the project. So the first thing that we need to do is trying to merge his current branch, his local branch, to master. Okay, and there are 2 ways to do this. The first way is called git merge, and what it does is basically it tries to merge the current changes, the additional changes on the current branch to the master. But the first thing we need to do is first we git checkout master. Again, checkout moves our state of the working copy to a different commit. In this case, it moves us to a different branch completely because we specified the master. Okay, so we do a git checkout master, and then we do a git pull -r, making sure that there are, to get all of the Bruce's changes, and then we do a git merge. Git merge basically will merge R106 with R107. Okay, and we specify the branch name. Any questions so far? I know this is a lot of probably news gibberish to you, but I'll try to explain it well. Anyone has any questions on branching? Okay, so the other command that is also used to merge branches is called get rebase, and this is what your friend was asking about. And what get rebase does is that it's kind of the same as get merge, but it saves the history of all the commits that happened on the other branch. Okay, so when you do a git pull tries to merge the remote repository with your working tree. When you do a git pull -r, it tries to rebase. And what rebases does is that instead of merging R06 and R106 and R105 together, it adds 103 and 106 as a new commits on top of the master branch. So it's going to be R103 prime, for example, R106 prime. Okay, so it replays whatever happened on the current branch on the other branch that you want to merge to. So this way, it makes it a lot easier when you read the git log history to see who did what or what changed in each branch. Is that clear? Okay, so I'm gonna actually draw it a little bit to just also make it more clear. Okay, so can you see this? Can anyone on top see this? No? Okay, so I don't think that will be possible. But basically, let me try to go back here. Yeah, so the master branch is going from R99 with additional Bruce's changes, and basically it continues normally, okay? And then Tony tried to do 103, 106. When we do a git merge, it will create a new commit that merges both states of the branches in that one commit. So when you try to see the changes in that commit, you will see a lot of changes and you will lose history of who did what basically. What did Bruce actually do in that commit and what did Tony do? While when you do a git rebase, it doesn't create a new commit, it just takes all of the commits on Tony's branch and adds them one by one to the extra branch. And this is the benefit of rebase. Basically, again, it saves all of the commits as if you were developing them on master, so that when you look at the log or you look at the history, okay, it's clear who did what. The problem with git rebase is that it can create a lot of conflicts if you don't rebase often, because it tries to basically add each single commit to the top of the branch. That means you will have to resolve conflicts for each single commit, even if at the last commit, all of the changes are fixed. You have to still do them one by one. Is that clear? Any questions? Okay. So we talked a little bit about the motivation why we use branches. In practice, we usually use them for two main things. One, what we call release branches. So for example, at Cerebrus, every 3 months, we try to release a new version of the software to the external customers, okay? So at that point, before the 3 months, like say every 2 months, we create a new branch, call it a release branch, and it takes the state of whatever on master to that branch. And this is the only software that we're going to release to the customer. Any changes that go into master after that will not be released because they need to be tested more and making sure that there are no bugs before releasing to customers. So this ensures that the software that we're releasing to customers is stable, it's well tested, and there are no issues in it. Okay. The new development or any extra features that are being added will be added to the master branch, but they won't be part of the release or the current release. They can be part of the next release. So if you remember when you worked on 241, you were using the Quartus version. So every now and then, basically, Quartus releases a new copy, and this is what basically, this is basically a new branch every 6 months or so. So the release branch stays forever. Basically, if any customer comes again and says that there is an issue with something in that release, we can check out that release branch, try to resolve the bug at that state of the program and push it and give it back to the customer. Because some customers don't want to update to the latest release just for some reason, like probably a missing library, or they don't want to upgrade all their clients or something. The second reason why we use branches is to do feature development. So usually in big companies, the master branch is locked, so no one can actually access the master branch directly. We can't write to it, and we can't add any additional code to it unless it is approved by upper management or by your colleagues, to making so that we make sure all of these changes don't hurt the development of other developers. So because master is locked, we basically, each developer creates their own branch. I, for example, create branches for every single feature that I'm working on that are different from each other. I finish working on that specific feature, and then I try to do what we call a pull request or a merge request. Basically, I'm asking other developers in the team, please look at my code. If it is okay, if it is approved, everything is tested and no bugs, then I can merge it or rebase it back on master, and now master will reflect my changes. Okay, so basically the two reasons we use Git branches is to do release branches, making sure that what we release to customers is free of any bugs. And the second thing is to do feature development in big teams. Now, I'm teaching you these basically because you'll probably hear about them or use them later in your career. You might not use them in this project. If you want, you are free to do so. But yeah, be ready to resolve a lot of conflicts. Okay, so I think we've talked about the main Git commits and how things work in Git, at least what you need to know for this course. Obviously, I didn't cover everything. Git is a very big topic, and there are a lot of resources out there that you can look at. I'm just going to go over some of the, recap on some of the commands that we use and that are beneficial for you in this course. Okay, so the first thing is Git status. What Git status does is basically gives you a detailed list of the change files currently that are not committed yet to the remote repository, and it basically tells you these are the files that you added. The other command is git log. Git log basically lists the info of all the commits and the history of all the changes that are made by each single developer. It gives you the name of the developer, the time that commit was pushed, and a commit message. That's why we tell you when you commit, try to write meaningful commit messages, because it will make it easier for other users to see what changed in that branch without seeing the actual code changes. Okay, and then git add file or git add dot basically prepares the set of changes that you want to be committed to be added to the remote repository. There is something I didn't talk about, is like we talked about the working copy, we talked about the local repository and the remote repository. There is something called in Git called the staging area. The staging area is what git add actually interacts with. So when you do a git add, it moves your changes from your working copy to this staging area. It's an implicit area in your working copy, and anything stored in that staging area will be tracked by Git and will be committed if you type git commit. Okay, so yeah, when you type git commit -m and give the descriptive message, it moves the data from the index area or the staging area to the local repository. Again, the local repository stays on your own machine, and it allows developers to work offline. And once you do a git push, it basically pushes whatever changes in the local repository to the remote repository. Okay, the extra commands are git fetch. Fetch is basically, it brings from the remote repository all the information that are there to the local repository. So if there are any changes on remote that aren't yet in the local repository, Git fetch basically tells you that there are changes, but it doesn't pull them. Git pull is what it fetches and merges the changes to your local copy. So yeah, with git pull or git pull-r, both of them basically try to get all of the changes from the remote to your local copy. The only difference is merge versus rebase that we talked about. Merge is basically tries to merge everything automatically. -r rebases is basically tries to replay all the additional commits on the remote to your local copy. Any questions so far? All good? Okay. And yeah, the last thing I wanted to talk about is basically, again, Git is a really big topic. I covered most of the things that you're probably going to use in this course. The main reference in our course is the quick start guide that we provided. There are other references out there that you can look at. My favorite one is this Atlassian Git tutorial. It's a pretty descriptive and with a lot of images that explains the different commands. So you can, even if you want to look at, for example, the difference between a merge and a rebase, it will give you that difference in detail. This is what I have in this lecture. I'll give it back to Professor Chong to continue on WD0. And the next time we meet, I'm going to start talking about the milestone 1 and the software APIs that you need to know for this project. Okay.
Okay, I think everyone should be able to hear me still. Okay, so let's talk about WD0, as that's the first deliverable that is due relatively shortly. I checked this morning, there are already 3 submissions, so 3 people have gone ahead and actually submitted their WD0 already. I would suggest that probably in the next 2 classes, we're gonna cover some things that may impact the way you want to respond. I looked at the responses, they were good, but they were maybe missing a few things that we'll talk about today. So what we want to do is really cover that deliverable and talk about some of the principles that we want you to take away from the course and apply to that particular principle, that assessment as well. Okay? So remember, there are 2 key components of this assignment, right? The first is the summary of the principle, which really we want you to use to show that you've read the book and you've understood what that principle is in a deep and kind of meaningful way. And then the second is the analysis of the presentation or the actual application of that principle, right? That I'm going to talk about next class. For the next 8 minutes or so, I'm going to try to get to an example of what we want you to do here, right? So briefly summarize the principle. 3 principles from made to stick. We want you to paraphrase. We want you to explain it in your own language, even though you can employ keyword quotations when necessary. So one of the things about engineering writing and writing in an engineering context is that you don't often use the exact words of a source and throw it into a document, right? In that case, you would have to quote to acknowledge that author, but this is because in engineering, it's the ideas that are more important than the actual words, right? So if you're in the humanities or in the arts and sciences, often the exact language is really important. But really in engineering, the key thing is to capture the idea, right? And that's what we want you to do. We want you to paraphrase, put it in your own words, and show your own understanding of that principle, right? So we looked at this idea of simple, and we've talked about it, I think, twice already. Just very briefly to say it's not compact, short, or easy, and it's more like compact and core, as in a proverb, not a soundbite. So there's a 5-word definition from the text of Made to Stick that kind of really does capture the essence or the core of this principle, right? But if you're going to use this in your definition, it doesn't show your understanding very well, right? It relies on a shared understanding of what a proverb is and what a soundbite is. And we want you to push a little bit further into the definition and into the book itself to come up with your core understanding of this idea. Now, this is the first chapter or the first concept that's discussed in the book. And it breaks down into, sure, simple means concise. That's one thing it definitely does mean. It's simple. But if you look at it, it breaks down into two examples. And this relates to how I was talking about how the examples in the book are really key to understanding the concept itself, right? So they talk a lot in the simple chapter about this idea of commander's intent, right? Getting to the core is to get to the commander's intent. And they talk about it using this proverb, right? So related to the way that they defined it before, they say, a battle plan doesn't survive first contact with the enemy. So you need to know what your core intent is. And the argument there is that once you're in battle, you may have all these ideas about what you wanted to do in specific process and stages. But once you're in that environment, you really need to know what your core intention was to accomplish that, because your steps are probably not going to work out that well for you. Okay, so now it's talking about, okay, finding the core, or the idea of this simple part of the message is stripping down an idea down to its most kind of critical essence, right? And if we push harder and we look at this text a little bit more closely, and you can do this for each of the principles, I'm only going to do simple, you get to the idea that it's a couple, that the idea of simplicity relates to a couple of things, right? A core intention, conciseness, and then leading to action in some way, okay? Now, a proverb also leads to action, right? The idea of a bird in the hand is better than two in the bush, right? That's a proverb. It's concise. It communicates a core intention, and it leads you to act in a certain way. So what does it do? Well, it means that you're not sacrificing what you have for some possibility of something in the future, right? Unless you're being really careful about that, right? And the idea that the one example I think is really illustrative in the book when they talk about simplicity is this idea that Southwest Airlines had, right? So they had this idea that Southwest Airlines was running under this core concept of being the low airfare carrier on that particular route, right? And they talked about an example where an executive came in and said, why don't we introduce Chicken Caesar to each of these flights, right? For the people who are on the planes. It's probably weird to you because you don't get food on domestic flights anymore, but you used to. But they asked that question. Does this contribute to the idea of Southwest as the low-fare air carrier for that particular route? And the answer was no. So that core intention, that simplicity behind that, also helped them to make decisions and led to a sort of action, okay? So we want to make sure that we're capturing in our definition all three of those components. Okay? Now I'm going to go very quickly through an example definition here. So this is something that I might see in a WD0 where we try to explain the concept of simplicity. I'll give you a couple of seconds to kind of read through that. And I'm just going to ask you, what do you think of this? So any initial thoughts on this definition of simplicity? This is actually pulled from a student sample. Sounds okay, but if you look at it, what do you see? Any thoughts? I'm going to call on somebody in a second. Can I call on B07?
I'm pretty sure like this is basically what the book says, so they don't actually define it like in their own words very well.
Oh, so you actually spotted the fact that the bottom couple of sentences is directly from the book. Yeah, it's a direct quotation. I was going to point that out after, but really that's an eagle eye. That's really good of you. I was going to start by looking, I was going to mention that, but I was going to start by looking at this first sentence here, right? In Made to Stick, the simple principle is presented as alluding to stickiness. That is ultimately a pretty meaningless sentence. It doesn't give you anything about the concept of simplicity. It's not very meaningful. It doesn't define it in any ways. Now, this does define one of the aspects of simplicity, but where does it happen? Happens at the end of this passage, right? At the end of the definition. So if you did this, you would be able to say, okay, I've made this more concise, but I haven't actually added any meaning to this, right? And so we want to make sure that you are taking the opportunity to very quickly deliver the core of that message, okay? And we want to get it down to here. So maybe you want to move that initial